So let's check a few things about this quiz. I'm going to give you some answers and you can do corrections on this quiz. So when we look through this, we've got adult tickets, we have the mean and the standard deviation. Children's tickets, we have the mean and the standard deviation. Adult tickets sell for $10. Let A equal the amount of money he collects from adult tickets on a random Saturday. What are the mean and standard deviation? So we've got $10 a ticket. The mean number of tickets is, for adult, 28 or 28.3. And so all we have to do really is multiply it by $10 for each ticket. And I think you get something like $283 for the tickets. Standard deviation multiplies the same way. So if it's 5.3 tickets, it should be $53 for the standard deviation. For the children's tickets, now down here, it's not asking for just children. It's saying let T be the money that he collects from all tickets. So this is for children and for adults. So basically what I did was off to the side, I did the same thing up here, but I did it for children's tickets, seeing the children's tickets sell for $6. So I made the mean number of children's tickets that he sells is 52.5. I multiplied it by 6 so I could see the mean number of dollars that he earned. I multiplied 8.1 by 6 so I could see the standard deviation in dollars. Then all ticket sales, you'd be adding them. Now the means we can just add, but the standard deviation is a little bit different. That's the one where you have to square them and add them together, and then that gives you the new variation, or the new variation. And then what you're going to be doing is you're going to be square rooting that to get the standard deviation. So that's a little help on that question there. The main problems came with, not C, main problems came with number 2. For C, it costs $300 for the manager to put on each puppet show. Profit from a random Saturday show. Mean, you can take all the money that you receive for part B and take away $300. That would give you how much the mean amount of profit is. Standard deviation, last I checked, addition and subtraction didn't affect standard deviation. So the standard deviation should actually remain the same as it was in this problem over here. Because you're not multiplying and dividing. Multiplying and dividing is the only one that affects the standard deviation. The main problems came in number 2. On average, just take a look. Mr. Voss gets about a 212 when he bowls, and Mr. Cole gets about a 230. Who does better? Mr. Cole. So the question is asking you, what's the probability that Mr. Voss scores higher than him? Now, the odds are not in his favor. So I don't think we should have like 90% if we just look at this problem, because their mean is really not, there's a difference of 18 between them, and Mr. Cole's been doing better, is basically what I think of. So I'm thinking, if we were thinking of like a general idea, I think we should be less than 50%, because it seems like he's got a mean of higher, that he's starting off with a mean of a higher amount. So I put a little hint at the bottom of this paper. On your paper, it said difference of Voss and Cole. And some papers got marked incorrect or had points taken off because they did Cole minus Voss, but then somehow didn't switch it along the way to represent the right idea. So let me go through it for you for a second. If we do Voss minus Cole, we would take Voss, who is 212, and Cole, and subtract them in that order. And we'd actually get a mean of negative 18. You could very well do Cole minus Voss, but then your mean should be positive 18, because you'd be doing 230, take away 212. So that's what I'm meaning, is that you can't just get 18. It depends on which order you put it in. If you put it like I did, Voss minus Cull, then you're going to get negative 18 for the mean. For the standard deviations, even though you're subtracting, this is the one where you still take the standard deviations, 31 and 40. You square them first, add them together, and that's going to be your new variation. And then you square root them, and that gets you your new standard deviation. So some people might not have done that correctly. And it says, assuming their scores are independent, what's the probability that Mr. Voss scores higher than Mr. Cull on a randomly selected Tuesday night? I did a z-score and found the probability. The only difference is when I did this, I did Voss minus Cull. So I got negative 18 for the mean, and then I got a standard deviation when working with the 31 and the 40. And I did a z-score, but a lot of people don't know when you do z-score, you have to do actual minus mean. So my mean was negative 18. The actual, people are like, well, what score is the actual? Well, Mr. Voss minus Mr. Cull, okay? Basically, where they break even is when they have the same number. So we want to know, where do they break even? And then we can say, all right, Voss minus Cull. We want Voss to be higher than Cull. So we want any score that's greater than 0 or 0 itself. Well, I guess 0 is our borderline. We want all the numbers greater than than 0 for when we're doing the z-score. So for my z-score, I did z equals, and I put 0 in for the actual because I want their difference to be nothing. That's going to be my borderline. And then I did minus negative 18 because that was the mean, and then I divided it by whatever the standard deviation that I got. It's 50 something like that. And then I found that in the table, I found what the z corresponded to for the probability. The only problem is that probability is giving me a bigger number than 50%. So when I'm looking at it, the probability is giving me 0 and less. Remember that chart, it's giving you 0 and less. What we're looking for is 0 or greater. We want Voss's scores to be higher than Mr. Cull, so when we subtract them, we want to get a positive number. We want to get higher. So you actually have to take that number and subtract it from 1 so you can get the greater than portion of the graph. Maybe that will help you with your corrections.